Okay. So these are the three scenarios, three reasons why virtual memory concept was introduced. Okay. Then virtual memory is a logical memory which is being provided by the system, operating system. It is a logical memory. Logical memory borrowed from auxiliary storage device, auxiliary device. So that is our hard disk. Right from hard disk, it is being taken here. Okay. So for doing this particular kind of thing, what exactly virtual memory can be followed? What exactly the specific hardware protection which is being followed by virtual memory here? What exactly it is being followed? So it is being followed one particular technique. The technique is called as demand paging. The technique is called as demand paging. What exactly the demand paging will be? How demand paging is being done here? Let me discuss with you within this entire session. Basic idea of demand paging is operating system should not give you all required number of frames. Okay, for example, just before I have discussed with you that one particular process might be required. So 200 frames, in the sense 200 frames will be gets allocated by operating system so that the process will be done as far as paging is concerned. As far as paging is concerned, how many number of frames are required? So those many number of frames are being given, and they will be occupied in the memory. So then it will be so process will be continued. But in demand paging, what exactly it is going to done here in the sense, when a page is required, then only that particular page will be loaded into the memory. So that is the particular point we need to understand. When a particular page or when a particular frame is required, then only that particular page is going to be loaded into the memory. So okay, pages or frames, pages or frames. Actually, the physical memory can be divided into frames, and the logical address space will be considered as pages. However, you can take anything. So pages or frames are load into physical memory when they need, when they okay, instead of writing need, I'd like to write as demand. When they demand, then only they will be load into the memory. Otherwise they could not be load into the memory here. As and when they need that particular process page or frame, that will be obtained from the backing storage device, that is auxiliary storage device. Okay. So what is the demand paging general hardware protection which is required here? So this is the general general idea for demand paging here. And demand paging, one more point to be remembered here in the sense, operating system will be allocates, OS is being allocated limited number of frames or pages to a process. As I said just before, 200 frames is required for the execution of your particular process. All 200 cannot be allocated for you. All 200 cannot be allocated for you. Okay. So load your page only as they needed to execute. So that is the slogan of demand paging. Load your page only they are needed, only when they are needed. So that is the actual actual slogan of the load the page. Let me write here, load the page as they are needed. They are needed or they are demanded. That's all. Operating system or CPU is being demanded. Then only it could be loaded here. However, so this is the point which we'd like to consider here. So demand paging does always, operating system can be always allocated very limited number of pages to you. All required number of pages cannot be allocated for you here. Okay. Let us consider, for example, as far as your problem is concerned, process is concerned, your process always always reside, not load here, reside into your backing storage device. Let me talk about this one for a while. Always your process is being resided in the backing storage device, something like this here. This is backing storage device. Otherwise, auxiliary storage device. However, you can take anything. Backing storage. Okay. And here you can consider these are the exact sizes of the frames here. Exact sizes of the frame here. You can consider these are the exact sizes of the frames and pages here. However, how much size it will be? By default, it is 4096 bytes here. That is 4 kilobyte each. So here in backing storage, whatever the size which is being stored, which is being created as a block, that block is called as a cluster. Each cluster size is just 4 kilobytes. That is 4096 kilobytes. 4096 kilobytes. Now, process 1, for example, if you consider, I'd like to write a particular thing here, that is process 1, so is being, this color is not visible to you, I think. So here, process 1 is being, so taken some 25 pages, 25 frames. All 25 frames cannot be given to you. Operating system shall not give, so 25 pages. Operating system shall not give 25 pages to you. Okay. So then let us consider this is your physical memory. Physical memory can be seen something like this. Physical memory in the sense random access memory. Random access memory will be given to something like this. Here, this is your random access memory. And of course, each and every random access memory, each and everything will be always divided into some fixed sized frames here. So these are different frames which are available for you. So these are different frames which are available for you as far as the random access memory is being concerned here. Okay. So let us consider this is first frame, second frame, third frame, fourth frame, and so on and so on and so forth. Okay, how many? This is called as a physical memory. Physical memory in the sense random access memory, physical memory. So simply speaking, RAM. And your process, as I said just before, your process required 25 frames to be required to occupy in the physical memory so that the process will be gets completed. But operating system cannot be allocate all these 25 frames. Operating system will gives you only so 3 frames or 4 frames to be done. Understand? 3 or 4 frames to be done. For our convenience, instead of 25, let me take it as, oh, it is being erased, I think. Okay, however, let me consider or take it as, okay, I'd like to consider it as some 8 frames, for example, 7 frames. Let me say 7 frames are required to total process is being converted or created with 7 frames. So this is the frame number A, and let me take some other color, then you could understand what I am writing here. Okay, frame number A. frame number B, frame number C, D, E, F, G, and H. Totally 8 frames are there with you. If eight of these frames are supposed to be loaded into memory, then obviously your process will be gets completed. But in demand paging, all 8 pages or all required number of pages for a process cannot be allocated. Okay, all things cannot be allocated here. So therefore, how this could be gets occupied here in the sense. So let you can see. So let me write a P1 here. Process one's page will be available here, starting page. Process one's, so second page will be available here. For example, this is, let me say B is available. Process one's third page will be gets available. Third page number is C is available. I believe that you do remember what is the page table structure. Page table structure is 2 by n by 2. Yes, n by 2. N by 2 in the sense, first one is page number, second one is frame number, and n number of rows will be there within that particular page here. So let me draw that particular thing here again. So let me draw that particular thing one more time here. So totally my process one page size will be this one here. Process one page size will be, so this one here. So as far as this particular thing, you can observe this. So first one is page number, second one is frame number. Let me write F and F, P and F. Please, you please write completely P and F. So page number and frame number here. So 0th page is available where? So first page, second page, third page, fourth page, up to 8 pages are required to be loaded into the memory. Then it will be done here. 0th page, first page, second page, third page, fourth, fifth, sixth, and seventh. Totally 8 pages. 0th page is available. Page number 0. Oh, let me write it inside the page number here. This is 0. This is 0 here. 0th page, first page, second page, third page, fourth page, fifth, sixth, and seventh page. 0th page is available. So at second frame number 2. So then first one is available at first page is available at so let me say fourth frame. Third page is available at seventh frame. So that is second one, seventh frame. Then what about remaining? So if I would like to continue my process, so I need to have, after completion of these 3 pages, I need to have, so one more page to be executed, but there is no space for me to take that particular page and could be executed by the CPU. Then what should I do? So for doing this kind of activity, so it has been, page table has been modified by introducing one more bit here. That bit is called as valid or invalid bit. That bit is called as valid or invalid bit. So this will be gets extended with one more column. That column is called as valid or invalid bit. Please follow me very carefully. This is VRI. V stands for valid. This is a page table. V stands for valid. I stands for invalid. And of course, if you consider your logical address space, will be logical memory space will be seen something like this. Your logical memory space will be seen something like this. You can observe. So this will be, so this is also taken what you call 2 by n. It is also 2 by n. 2 by n does means page number and displacement will be there with you. Page number and displacement could be there with you. So this is 0th page, first page, second page, third page, fourth page, fifth, sixth, and seventh pages. 0th page, first page, second page, third page, fourth page, fifth page, sixth, and seventh. Totally 8 pages are there. 0th page information is available at A. as far as the process is being concerned. It is available at B, it is available at C, it is D, it is E, and it is F, it is G, and it is H. In this way, the logical address space will be available with you. Logical address space is available with you. Now you can see, as far as this particular page table, one more column was added. One more column was added here. So here, so 0th page is required to me whether it is existed within the physical memory or not. Yes, it is existed. Since it is existed, it will be considered as, oh, sorry, not invalid, valid. Sorry, valid. So valid bit will be refers that. What do you mean by V here in the sense? If that particular page is available with a frame of physical memory, then the bit will be set to V. Valid does means if that particular CPU wants to execute some set of instructions, those set of instructions are available with a page number 0. Let me give one example, page number 0. Does page number is existed within the main memory under a frame or not? Yes, it is existed. Page number 0 is existed at frame number 2. So that is why page number 0 against to page number 0, valid or invalid will be, this bit will be set to V. This bit will be set to V. Of course, page number 2 is available in frame number 4. It is also set to V. Page number 2 is available, so at frame number 7, of course, it is also valid. Then page 3, 4, 5, 6, 7 are not existed in the main memory. They are in backing storage, not in the main memory. So therefore, all these things will be set to invalid. These are set to invalid. I does means the page is not available with you. With you in the sense in physical memory. That is the meaning. All these pages are not supposed to be available. Okay, they are not available. Now CPU has generated one address. For example, let us don't write this one. Just wait for a while. Wait for my instruction here. CPU generated one address, so that is 0, 1. So this is the address which is being generated. 0 is the page number, 1 is the displacement. 0 is the page number, 1 is the displacement. Does 0 is existed within the page table? Yes, it is existed. You can see 0th page is there. Against to 0th page, any frame has been filled? Yes, it is filled. Against to page number and frame, was it valid? Yes, it is valid. What do you mean by these three fields here in the sense? Page number is existed, frame number also given something, and bit was set to valid. So therefore, this particular page was available with so specified frame number here. The frame number is 2. Within 2, everything is available. Okay, therefore you can of course using paging, so it will be, I mean, using the paging mechanism, so it is going to get the instruction to be executed. Okay, for example, CPU wants to execute one particular page, something like this. So some 3, 4. So 3 is the page number, 3 is the page number, and the 4th instruction under page 3, 4th instruction is trying to execute. So look at this. This particular 3 is available with D here in logical address. It is available with D here, and address will be, so logical. This is actually logical memory has been specified something like this. This is logical address here. 3rd page is available within the particular page table or not? Yes, it is available. But as far as so the frame against the 3rd page, it is empty. And if you consider the valid or invalid bit, it is invalid. So the page is not available within the frame, within the physical memory. So the page is not occupied any frame within the physical memory. So this kind of scenario is called as page fault. Page fault. Page fault does means when CPU wants to execute page fault. Page fault does means when CPU wants to execute any kind of instruction, so that it could be generated one logical address, and that logical address is always trying to look into page table. Within this particular page table, if valid or invalid bit will be set to I, that is invalid, therefore the page is not existed in physical memory. Okay, if page does not existed in any one of the frames of physical memory, such kind of scenario is called as page fault. So when page fault is occurred, operating system should be responsible to take that particular page, identify where exactly that page will be in backing storage device. That must be copied from so-called frame which is available for you within the physical memory. Okay, when process is trying to access a page, let me write the definition for this one. Process is trying to access a page fault. Trying to access a page to execute, which does not existed in the in any frame of the in any allocated frame of the physical memory. Physical memory is called as page fault. Page fault is because of operating system does not allocate you enough number of frames to you. Operating system does not allocate enough number of frames to you, so therefore page fault will be gets occurred. How do you identify the page fault here in the sense? Page fault will be identified in the page table, valid or invalid bit will be so identifies as I, something like this I, then obviously you can say that is not available within the physical memory. Then what shall we have to do? This diagram, not this particular diagram, coming diagram is very important. Coming diagram, while talking something about your final examinations, demand paging coming diagram, whatever the diagram I am supposed to give you, that is very important for you. Okay. So then when a page fault will be gets occurred, what exactly we are trying to do? What exactly our process will be do? So your process or CPU can immediately do this particular kind of operation. Immediately can do this particular kind of operation here. So what exactly it could be do? So look at this. There are 6 different types of operations which are available. I mean procedures which are available. 6 steps are there here. When so please concentrate while I am speaking something to you at this moment. So here, wait for a while. I'll come back to this particular area one more time. So here, CPU wants to execute third page. So first page, 0th page is over. First page is gets over. Second page also gets over. You have allocated only these frames. You have allocated only so frame number 1. This is the first frame which was allocated to you. This is second frame which is allocated to you. This is third frame which was allocated to you. Only three frames have been given. 3 frames has been allocated for you. No other frames will be given to you. So within this particular 3 frames, you are trying to load the particular thing here. So there is no problem at all. So in the initial time, for example, if you understand the scenario at this moment, in the initial time, so no process is available with you, right? No process is available with you. So look at this. Sorry, no frame is available with you. Your allocated frames will be this. So look at this. So this particular frame does not exist, and this particular frame does not. Every frame is empty. Your process has not been loaded into so even single page into the So particular frames which have been allocated for you by the operating system. Now, so CPU wants to execute this particular kind of instruction. So, however, you can see, so you can see this is also empty. Okay, however, so this is also empty here, also empty here, also empty here, and this will be set to invalid. This is also set to invalid. Look at this, everything is so empty. I'm talking something about. So what is this? Pace fault. I'm talking something about pace fault. Okay, and swapping also. I'm talking about these two, and swapping also. Look at this. Now CPU wants to execute the first instruction something like this here. 0th page, and this is invalid. This is also invalid. This is also invalid. So 0th page, first instruction is trying to execute by CPU. The logical address has been generated something like this. Now refer to the page table 0th page. Nothing is there here, and our valid invalid bit is invalid. So page is not available. Immediately, so this information is sent to operating system. I'm trying to execute something, but which is not available with me. So what should I do? So invalid in the sense page fault will be existed. Since page fault is gets existed, this page fault will be reported to operating system. Operating system will identify where exactly the page 1 will be. That is, 8th page will be. This particular page will be gets identified in the backing store device. After identified, does your allocated number of frames are free or not? Yes, these three are free right now. Therefore, 8th page is going to be loaded into this particular area. Okay, that particular area. And A will be filled within this. Update the page table here. Update this particular page table here. Okay. And then modify this particular bit from invalid to valid. Now your process is being get started. Resume back, and it will be execute whatever the instructions which are being there with the page number A. Things are done. Now after some time, so CPU has been generated. Let me write here. CPU has generated one more address. That address will be so page number 1 instruction 0. Wanted to execute this one here. CPU has been generated as a logical address, something like this here. But this is not available here because against page number 1, so nothing, no frame has been mentioned, and valid invalid bit will be invalid. So page fault is again occurred. What exactly operating system? This information will be forwarded to operating system. Operating system now look into backing storage device whether so-called B page is available with the operating with the backing storage device or not. If it is available, then immediately whether so your allocated frames are free or not. Yes, page is free. So therefore, it has been allocated to me something like this. B is allocated to me. Now here it is B against this one B, and invalid will be make into valid. After some time, so logical addresses have been generated, number of pages will be the number of instructions are there will be generated. That things are over. After some time, logical address one more after completion of this frame execution. After some time, it is going to generate 2,0 again. 2 is not available. Okay, 2 is page table 2 is not available. 0th instruction is not available. Same process will be done, and again this particular C page will be, it is free because it is free. So it has been loaded into, so this particular thing here, so it will be loaded into C here, and it is valid. As of now, all the frames which are allocated to you are free. There is no problem at all. So everything is rolling. Page A is rolling. Roll in. Let me say swap in. page B does also swap in, page C also swap in, because all the frames are available for so store new coming pages. Now the problem will be after some time, so logical address which is being generated by so 3 comma 0. 3 will be the page number and 0th instruction is going to be executed. But here against 3 comma 0 it is invalid. What exactly? The same information, that the same trap is being forwarded to operating system. Operating system is looking forward that whether page is available or not. Yes, it is available. Then it is also looking for whether allocated frames are free or not. Previously everything is free. Previously everything is free. There is no problem. There is no other mechanism is not required. Other mechanism is not required. So therefore, now it is going to replace. It is going to replace one of these 3 pages, because so no other frame is allocated to you. Only 3 pages are 3 frames are allocated to you. So it is going to replace one of these frames here. So now one rollout will be there, swap out will be there, and a new page will be swap in will be there. Now let us consider very long back the page A has been entered. So this will be not exactly this one. Let me talk about for a while. So this will be swap out, and in this place D is going to swap in. Now this will be eliminated here. This will be make it as invalid, and here it is 2. Where exactly 3 will be available. Yes, 3 will be available at 2. Wait for a while. In this place, sorry, in this place 3 will be available here. So here let me take another color. So here C D will be replaced here, and here it is valid again. Wait for a while. What I have written is not proper. Yeah. Page number page number 2, page number 0 is available at 2. Wait for a while. 3 was D is page number 3. Yes, here it is. D is available here, and it will be make into valid. Okay. Of course. So this is page table is 3. D is available, and it must be there with. However, let me talk something about this one after some time. So this will be done here. In this way, if it is not available, so that could be obviously do some kind of activity here. Okay, like this continuously it is being done. So sometimes only swap in, sometimes only swap out. So doing this particular scenario, so try to concentrate what I am supposed to give you coming 5 minutes. Wanted to load one particular process, one particular statement or one particular instruction. Wanted to load one particular instruction here. So let me call it as that instruction might be something here. Load M. When load M is being done, immediately it is looking into page table. Immediately. So this is a let me consider this particular thing is the logical address, and this will be immediately look into the page table, something like this. Immediately it is look into the page table, something like this. Okay, it should be look into the page table. For example, this is invalid. This is invalid. This is invalid. Now this invalid is called as, this is the first operation which is being done. Number one operation is refer to, let me write at the end. Number one operation is refer to page table. Okay. And if it is invalid, immediately this will be informed to operating system. I got an invalid kind of thing. A trap is being occurred. This trap is being notified to operating system. So here it is reference. This is a trap, address trap. Trap in the sense error. Don't consider any other thing. What exactly operating system should do here in the sense, operating system will be obviously looking into backing storage device that that page is available with you or not, with the backing storage device or not. Whatever the page which is being referred, that page is available or not. Okay. If that particular page is located by, okay, so this is a third operation. Operation number 3 will be page is on backing storage device. Backing storage device or not. If it is identified, immediately what exactly she is supposed to do? Supposed to do whether free frame will be existed or not. Whether free frame, this is physical memory. This is physical memory. This is backing storage. So identify the free frame. Of course, it could be done either swap in or swap out. Swap in or swap out will be done by this one here. Swap in or swap out will be done. Free frame. Identify this particular free frame. Okay. After identifying this particular free frame, so it will be load into this particular free frame. The page will be, this is the fourth operation. Okay. So bring the missing page, bring the missing page to page table. Sorry, physical memory. Physical memory. After that, what she is going to do here in the sense, it is going to adjust the fifth one. So reset the page table. Reset the page table. After that, restart our process. Sixth one. Okay, restart instruction. First, it is going to refer to the page table. If that particular thing will be invalid, the trap is going to inform to the operating system. Operating system will be looking to the backing storage device, whether it is existed or not. If it is existed, also look into memory for free frame. If it is available, then the page is copied from backing storage to physical memory. Then